Okay, now we're going to use the factor theorem to determine whether x minus c is a factor of fx. Let's see. So we're given fx equals to x cubed plus 8x squared plus 19x plus 12. And our xc is going to be x plus 3. So we know that x plus 3 equals to x minus c, right? What you're going to do is you're going to evaluate your function at the number that is at x minus c, at your c, right? So plus times minus gives you a minus. So your c is minus 3. So let's evaluate f at minus 3. Just put the minus 3 at the x's. Minus 3 cubed plus 8 minus 3 squared plus 19 times minus 3 plus 12. Put it into your calculator and you are going to get a 0. So since you got a 0 when plugging in the c at your function, then that means that x minus c is a factor, okay? Is a factor of your polynomial. So the answer would be yes. It is a factor of f of x, x minus c. And if you get any number that's not 0 here, then it's not going to be a factor. Okay, it's as simple as that. Now, let's do another type of problem. It says, list the potential rational zeros of the polynomial function. Potential rational zeros of a polynomial function without finding the zeros. So let's list the potential rational zeros of f of x equals to 11x cubed minus x squared plus 3. How are you going to find the potential rational zeros? We're going to look first for our p and our q. Now our p is going to be factors of the last number of your polynomial. Okay, factors of the last number. And our q, factors of the first number. Okay, now let's see. P, factors of 3. 1 and 3, right? But you're going to put a plus minus sign before them. Plus minus 1 and plus minus 3. Factors of q. It's going to be plus minus 1 and plus minus 11. Now what we're looking for is PQ, right? So P over Q. P over Q equals to P over Q, 1 over 1 is 1, so plus minus 1. 3 over 1 is 1, so plus minus, 3 over 1 is 3, so plus minus 3. Then 1 over 11 plus minus 1 over 11. And plus minus 3 over 11. And those are your potential rational zeros. Now let's move on to another type of problem. Whoa. What happened there? Okay, there we go. Let's see. Use the rational zero theorem to find all the real zeros of the polynomial function. Then use the zeros to factor f over the real numbers. Okay. What we're going to do here is this. We have f of x. Oh, what happened there? F of x equals to x cubed minus 5x squared minus 61x minus 55. And we know that this function right here has 3 zeros because the degree is 3. We're looking for those. We're gonna look for those 3 zeros. You would normally have to look for the p and q's and then test the pq's. We're doing some long division, but not on your midterm, because on your midterm you're gonna have your options. One of your options is going to look like this. f of x equals to x plus 1, x plus 5, and x plus 11. So you know from that one of your zeros is -1 and the other is -5 and the other is -11. So what you're going to do is you're going to take out your calculator and you're going to graph the function. So x cubed minus 5x squared minus 61x minus 55. Go to your table and look for the -1. So you have a 0 and -1, and then check for -5. Have a 0 and -5, and let's see, what do we have at -11 or 11? Oh, it's 11. Yeah, that was 11. We have a 0 at 11. So you know that your zeros are -1, -5, and 11. Okay? That was -11 over there at the yellow thing. So yeah, those are your zeros. That's the only thing that you're looking for, zeros.